Okay, let's talk about identically equal polynomials with the same coefficient. So in the last video, we left off by finding two polynomials that would give us the same. So now we can make a claim, or we can justify the claim, that if two polynomials p of x and q of x are identically equal, so if p of x is equal to q of x, okay, for all values of x, then the corresponding coefficients of the polynomial, so when you expand both of the polynomials out, are equal. So then the coefficients are the same, and they have to be the same, otherwise they're not going to give you the same values. Okay, now there's a really easy proof for it, but we're not going to really talk about that. But essentially what we've got now is we've got a toolkit for ways to factorize different polynomials. Now, the last thing we need to talk about is some geometrical implications of the factor theorem. So the graph of a polynomial function of degree n is completely determined by any n plus 1 points on the curve. So what that means is, if I wanted to draw a straight line, for example, all I need is 2 points. Okay, because there is only 1, 0 of a straight line. Okay, if I can define any 2 points, then it must make that line. If it was only 1 point, say this one, I could draw a line that goes like that, a line that goes like that, a line that goes like that. There's lots of different points. But as soon as I add another second point in, I have to be talking about this line here. So n plus 1 points defines exactly an n0 graph. Okay, so another example of that is a parabola. So if you draw 2 points, there are technically 2 parabolas that you can draw from it. You can draw the one that goes like this, but drawn properly. Ugh. Okay, or you can draw the one that goes like that. However, as soon as you draw 3 points, so let's say I draw this point, and this point like here, there's only one parabola that goes through that exact line, okay? So 3 points, 2 zeros, okay, or at most. Which in this case, it's this one here and this one here. So I hope that kind of makes sense, but the idea is that essentially if you're drawing, so like a polynomial, a parabola, something like this, okay, has degree 2, then you need 3 points to draw specific ones. Okay, now number 2 is the graph of 2 distinct polynomial functions cannot intersect in more than the maximum of the 2 degrees, okay? So what that's basically saying is, if I was to say, let's draw a cubic, okay, so some cool cubic like this, okay, which is p of x is equal to x cubed plus some b of x squared plus some c of x plus d, and then I drew q of x, which is some line, mx plus c. So the degree of this one here, the top one, is equal to 3. The degree of the bottom one is equal to 1. So basically, if I was to draw some random line, then it can only intersect the first graph, that cubic graph, of at most 3 points. So if I draw one that goes like this, then it goes through 1, 2, 3. If I draw one that goes like that, you've got 1, 2, and 3. It doesn't mean, however, that it will always go through 3 points. So if I draw one like that goes straight up like that, okay, so that this one's going to grow. Oh, actually, I think it might eventually catch it. But the idea is, well, if I drew a vertical line, okay, so a vertical line straight up and down, like not like that, but like this. Okay, so a vertical line like that, it has 1 point there. Okay, but the idea is that you cannot have more than the maximum of the 2 degrees. Okay, So, you know, if you had a degree 5 polynomial and a degree 3 polynomial and you put them on top of each other, then at most it's going to intersect in 5 spots, okay? So it's the maximum 2. And the third point, a line cannot intersect the graph of a polynomial of degree n in more than n points. Okay? So basically what that one's just saying is just saying if it's a straight line can do the same thing too. So in parts, so what I said for secondly and thirdly, points where the two curves are tangent to each other are to be counted according to their multiplicity. So basically, if you have a multiplicity of a... I don't think we've actually talked about multiplicity yet. I'm going to leave that one, but we'll talk about that one later on. Anyway, with that being said, let's have a look at an example. I've got to change this one. So the example 4. So by factoring the difference, f of x is equal to p of x minus q of x, describe the intersection between the curves p of x and q of x, and find where p of x is above q of x. Okay, so first let's just subtract the 2. So to find f of x, that's equal to p of x minus q of x. So p of x is x to the power of 4 plus 4x cubed plus 2. And we're going to subtract x to the power of 4 plus 3x cubed plus 3x, like this. Okay, so that's x to the power of 4 plus 4x cubed plus 2 minus x to the power of 4 minus 3x cubed minus 3x. Okay, so working this one out, so that's going to cancel with that. 4x cubed minus 3x cubed is just equal to x cubed. Then we've got minus 3x, and then we have the plus 2, just like that. Okay, so now what we need to do is we need to factorize this, because it's saying by factorizing the difference. So to factorize this, okay, we're going to look for some zeros. So let's substitute some values in. I'm going to try f of 1. So 1 cubed minus 3, lots of 1, plus 2. Well, we know that's 1 minus 3 plus 2, which is equal to 0. So therefore, x minus 1 is a factor. All right, let's look for another factor. I'm thinking maybe we'll try minus 2. So minus 2 cubed minus 3, lots of minus 2, plus 2. That's equal to minus 8 plus 6 plus 2, which is equal to 0. So therefore, x plus 2 is a factor. And I should write of f of x. Just like that. Okay. So now that we've got some factors, let's do some long division. So divide x by x minus 1, x plus 2, which is equal to x squared minus 2x, no, it should be plus 2x minus x minus 2, which is equal to x squared minus x minus 2 plus x minus 2. Did I do that right? 2x minus, yeah, okay. So we're going to divide our original function by that. Well, sorry, that difference function that we came up with. So we've got x squared plus x minus 2. So this is just to find what the third factor is, because remember, our difference is a degree 3 polynomial. So it should have a degree. It should have 3 zeros, like that. Okay, so our function that's going underneath is x cubed, and I'm going to go minus 3x plus 2. Okay, and I'm going to divide it out. So x cubed divided by x is equal to x. So x times x is x cubed. X times x is 2x. Oh, sorry, x squared, and then minus 2x, just like that. Subtract them, and we're going to get, well, this is 0 minus x squared, so it's minus x squared. Minus 3x minus 2x is equal to minus x, and plus 2 is left over. And I don't know why it's gone all big all of a sudden, but that's weird. Anyway. So plus, nope, Still not right. Minus x plus 2. Okay, just like that. So once we've done that, we can say to ourselves, okay, let's divide it through again. So minus x squared divided by x squared, well, it's just minus 1. Okay. And we're going to get minus 1 minus x squared. We're going to get the minus x, and we're going to get the plus 2. So it's going to give us 0 as a remainder. So that means our third factor is x minus 1 again. So we've got a factor of x minus 1, we've got a factor of x plus 2, and we've got a third factor of x minus 1 again. So therefore, f of x is equal to x minus 1 squared, lots of x, plus 2, like that. Okay. Now, what this means is that we've got y is equal to p of x and y is equal to q of x, a tangent at x is equal to 1, but do not cross there. Okay, so let's just have a look now at a sketch of this, just so we can see what we're doing. Okay, so I'm actually going to put both my things in. Plus 4x cubed plus 2. And we've got x to the power of 4, 3x cubed plus 3x, okay? And the function, oh, we better call this something, so p of x q of x, and f of x is equal to p of x minus q of x. Okay, so looking at this, here's the quadratic that we came up with. So x minus 1, there's the double root there, and the x plus 2, which gives us that single root, or single 0 there. Okay, so the original question says we want to find where p of x is above q of x. So how can we use this to tell us where it's going to be? So p of x and q of x are going to be tangent at x is equal to 1 because there is a double root there, but because it's only a double, it's not going to cross. So if we have a look at these ones, you can see at x minus 1, or at x is equal to 1, if we look up, that's not right. Looks like it's a bit further along when they become tangent. But the idea is that at this, there should be a point where they, oh yeah, no, this is where they come together. So this one and this one, they start to head in the same direction at x is equal to 1. Oh wait, I'm looking at the wrong bloody thing. No wonder. X is equal to 1 here. So if we got to 1 at 7, basically, they're going to, that's where they're going to intersect. And as you can see right there, that is that there. So what we've done, can I zoom in any further, I wonder? Oh, it's bloody close, that's for sure. So basically, if we zoomed in close enough, that's as far as I could get. If we zoomed in close enough, at x is equal to 1, so up here at this value of 7, okay, that would be the point where these two curves are actually going to touch. And we know that that's the case if we look at the difference of the two. We've got this turning point here at the 0 for the polynomial. So at x is equal to minus 2, they should also cross 2. Okay, so if we look at the other ones as well, okay, at x is equal to minus 2, okay, here we go, look, there they go, they cross there. So basically the zeros of the difference are telling you where these lines are going to cross. So the two lines, p of x and q of x, are going to cross when x is equal to 1 and x is equal to minus 2, which we worked out from finding the zeros of the difference, okay? So once we found the zeros of that difference, okay, that's going to tell us where it's going to cross over. But because this one headed back up, they aren't, well, they touch at that point, but they won't cross But this one here, because it goes from one side to the other side, they do touch at this point and they also cross over. So P of x and Q of x, if we have a look at -2, you see the red one comes down and it keeps going, but the blue one comes down and it crosses over. And that makes sense if you think about it as well, because if you're taking the difference of the two graphs, when the difference of it is equal to 0, you're expecting both the values to be the same. So what this is saying is -14 minus -14. So you should get 0 as your answer. So when you put the difference of the two, you get your 0. Now, the reason it crosses over, okay, you're essentially changing from positive to negative. So think about it like this, like your value is changing from a positive, so your first value is changing from positive, your first value is changing from being the bigger number to the smaller number. So if you think about it, like if you had, 1 minus, or let's say 5 minus 4, and then that all of a sudden changes to 3 minus 6. Like the sign's going to change, and that's where this change happens here. And essentially, the one value goes from being the smaller one to the bigger one, and the other value goes from being the bigger to the smaller. And so that's where you're going to get. So essentially, anywhere there's a double root, the graphs are going to be the same. Anywhere there's a single root, the graphs are going to cross over. Okay? Now, because f of x is positive for... so essentially now it's just a matter of finding, well, when is it positive and when is it negative? So what we can do in this case is we can actually just substitute some values in using our points. And we can use a table of values. So, or a table of signs, I should say. So we could go, okay, P of x and Q of x. I think that's what we've been using. Yep. Okay. Now, they're either both going to be positive, one's going to be positive, one's going to be negative, or they're going to be different. Now, our values that we're looking at are, again, these like magic values, okay, that we use for our factors here. Okay, so we've got -2 and we've got 1. Let's put -3 on this side. Let's put 0 and let's put 2 on that side. Okay. So we know that this one here, this should be, x, not P of x. And then we'd have Q of x underneath it. Like that. So we know that they're both going to be 0 there. Okay. Or they're both going to be the same. Now we just need to have a look and see what happens in between. So, 0 is... So, let's substitute the values into... Sorry, we shouldn't be doing P of x. We're getting this all bloody muddled up. We should be using f of x. Because f of x is going to tell us what's going to be happening. Now, if we substitute these values into f of x, so put 0 into this, we're going to get 0 minus 1 squared. Well, that's positive. Positive times positive, that's positive there. Okay, when it's equal to 2, you get a positive times a positive, so it's positive there. And when you put a -3 in, you're going to get -4 squared. So it's going to be negative. Okay. So basically what this is saying, remember the original question is P of x minus Q of x, or f of x is equal to this. Okay. F of x is equal to P of x minus Q of x. Now the only time that P of x minus Q of x is negative is when Q of x is bigger than P of x, okay? Think of it like, 4 minus 7. That's going to give you a negative answer. Whereas if you had like 7 minus 4, then it's going to give you a positive answer. So f of x is going to be positive when P of x is bigger than Q of x. Okay? So essentially, we can work out what it is just from that difference value. So, when is f of x... So the question is, when is P of x above Q of x? Well, it's when P of x is bigger than Q of x, or in other words, when f of x is positive. So, it's bigger than that when it's in between these two values here, and it's everything bigger than there. So, P of x is greater than Q of x when, and we go -2, less than x less than 1, and x is greater than 2. So it's a lot of working out for the one question, but I mean, you know, like we're getting to the tough stuff now. With that being said, I'll be able to help you guys with whatever you need help with anyhow. And yeah, with that being said, that's the end of the different complications, or not complications, but the different results. So what we're going to do in our next lesson is going to look at the sums and products of zeros, and then we're going to be looking at some other stuff to do with polynomials too. But we're getting towards the end, and so I'll leave you guys with that one.